channel. Guys, our first exercise today. Guys, come on now. Our first exercise is going to be practicing writing the expressions, but we're also going to be substituting. So I'm going to show you what to do on the first couple, and then we'll give you guys some time to work on this by yourselves. So what you're going to do is on the front side of the paper where we have the writing, you're actually going to read what it says and write the expression based on what it says. So Paul had X baseball cards, and he gave 5 to his brother. So I now write that as an expression. So I had X, and I gave away 5. So X minus 5. That's it for the front side. Now I'm going to turn this over. Micah, say Chris Paul one more time, and I'll go ahead and write your parents and tell them just go ahead and start it to listen. Don't be sorry. That's already your third time today. Behave. You know what to do. Now, I'm going to take whatever expression I wrote in box 1. I'm now going to write it on box 1 on the back side. So I write X minus 5. Now they've given me a value for X, so I'm now going to substitute that value in, 34 minus 5, and now I'm going to solve it, 29. Okay? So for those of you that didn't get it yet, let's go back over here. So now I'm going to go to box 2. Box 2 says the sum of X and 9. So mathematically, how I write that is X plus 9. I now turn the page over to box 2. I start with X plus 9 because that's the expression I had in box 2. I now substitute the value that they have given me. It now says X equals 14. So 14 plus 9. So my answer is 23. I've now solved the expression. Everybody understand now? So you're going to do that for all 25. One side note. The boxes in the back are in rows of 4. The boxes on the front are in rows of 5. That just means it's going to be slightly off as you continue down the page. But every box has a corresponding one on the back page. So we're going to give you guys, you got 22 problems left to do. They shouldn't take you long. We'll give you guys 12 minutes. Go ahead and go.
All right, guys, let's go over these. I'm going to do the whole front of the page first, and then we're going to do the back, so I don't have to flip back and forth the whole time, okay? All right, so let's look at number 3. Beatrice shared her 30 pieces of candy with X friends. So if she's sharing them, what operation is she doing? Division. So what is my problem? 30 divided by X. I can also write it 30 over X. Either one will be fine. Number 4, the difference of 7 and Y. Who can tell me how I would write this expression? Avi? Yes, 7 minus Y. Difference means subtract, guys. Number 5, 6 more than the product of 4 and Y. Who can tell me what this one is? Maddie? Okay, you have all the right parts, but what does more than mean? It means adding, but it is also a flipping phrase, meaning the 6 is going to be at the end of the problem, and 4 times Y is at the beginning. Guys, you can do 4.y, but you cannot do 4xy. If you use the x for multiplication, it is wrong. Number 6, this one's not numbered. Here we go. The product of 6 and x. How would I write that? Lucinda? 6x. You could also write 6.x. But if you wrote 6xx, it's definitely wrong. Number 7, John earns $5 for every hour he works. How much money will he earn for X hours worked? Akia? 5x or 5 times x. Yes. Number 8, the quotient of y and 11. Jonah? Yeah? Not quite. Y divided by 11. Quotient means divide, guys. Or you could write y over 11. Number 9. 8 less than the product of 5 and x. Hayden? 5x minus 8. When you see the word than, it means it's at the end of the problem. Number 10, 8 increased by y. Yes. 8 plus y. Number 11, Patty added $30 to the money in her savings account. Sophie? It says added to, so I'm going to do m plus 30. Does that make sense? You want to do one? Okay. Y decreased by 7, Deanna. Yes. Number 13, Carl bought 4 packs of gum with X pieces in each pack. How many pieces of gum did he buy? Yes. Say it again. Yeah. 4 times X. Or 4X. Number 14, the product of 9 and X. Nate? 9X. 9 times X. Y less than 11. Mateo? Yes. 11 minus Y. There's that word. It means to put it at the end. Number 16, 3 times the sum of X and 4. Nora? Okay, tell me how to write that. Okay, according to the order of operations, what am I going to work first? The multiplication. I'm going to do 3 times X. But it says I need the sum of X and 4. So how do I show that I'm going to do that part first? Losena? Yes, parentheses. And you can use the dot for multiplication, or you can just put the number in front of the parentheses because that automatically means multiply. Okay? Number 17, Marley had X dollars and spent $8 at the store. Wow. Cannon. Well, number 17, Marley had X dollars and spent $8 at the store. How would we write that? Yes, X minus 8. Good job. Number 18, 4 less than the product of 6 and Y. Lucena? 6Y minus 4. Yes, we are multiplying 6 and Y and then taking away 4. Number 19, 5 added to the quotient of 9 and Y. Kaylee? Nine what Y? 9 divided by Y plus 5. Good job. You could also write 9 over Y plus 5, guys. W more than 10. Yes. Yes. Well, no, it says more than. There we go. All right, so now I'm going to go to the back page, and we are going to write the expressions and solve them. So let's look at it. For number 3, we had 30 divided by X. So if X is 5, Mr. Moore, can you lock this for me, please? So if I have 30 divided by 5, what is the answer, Kaylee? 6. Thanks. All right, number 4, we had 7 minus y. If we replace y with 4, what do we get? 3. Okay. Number 5, we had 6 more than the product of 4 and y. So if we replace y with 8, what are we doing with 4y? We're multiplying. So I would have 4 times 8 plus 6. What is 4 times 8? 32 plus 6? 38. Guys, I really don't like talking over people. So if you're not answering my question, then you don't need to be talking. Number 6, we had 6x. So what does it mean we're doing? Multiplying. There we go. So 6 times 10, 60. Number 7, we had 5x. So if we replace x with 20, how much money does he make? $100. Number 8, the quotient of y and 11. So I had y divided by 11. So if y is 88, what is our answer? 8. Number 9, we had 5x minus 8. So if x is 12, what is 5 times 12? 60 minus 8, 52. Number 10, we had 8 plus y. So if y is 23, what do we get? 31. Number 11, we had m plus 30. If m is 270 plus 30, how much does she have in her account? 300, and that's money. Number 12, guys, that last table needs to break up because it's just, I don't understand. It's constant. Y decreased by 7. 12 minus 7 is 5. 13. We had 4x. So if x is 7, 4 times 7 is 28. 14, we had 9x. So if x is 8, 9 times 8 is 72. 15, we had 11 minus y. So 11 minus 7 is 4. 16, we had 3 with x plus 4 in parentheses. So if x is 11, what's 11 plus 4? And 3 times 15? It's 45. 17. We had x minus 8. So if 24 is x, what is 24 minus 8? 16. 18, we had 6y minus 5. Sorry. Yes, 4. So if 5 is y, 6 times 5 is? 30 minus 4 is? 26. 19, we had 9y plus 5. So if y is 6, I have 9 times 6. What's 9 times 6? 54 plus 5? 59.
To the quotient.
Oh, thank you. I don't have it written. So, all right, let's try that again, guys. I had 9 divided by y plus 5. So if 9 is divided by 6, what is my answer? Hayden? Nope. Nope. 1.5 or 1 5/10 or 1.5 plus 5 is 6 5/10 or 6.5. Whether you put it as a decimal, that means half. Make sense? And number 20, W more than 10. We had 10 plus W, 10 plus 15, and that is 25. Any questions about writing expressions and substitution? Yes? 12 is 5. It's 12 minus 7. It's 5. Anything else? All right, take out your books and open to page 108.
And we're going to look at what makes a number sentence true or false. Intuitively, you already know. So if I give you something, you say, no, that's wrong. That's a false statement. If I give you something and it's right, you know that's a true statement. So we're just going to use these words true and false. But we're also going to explore the other options, okay? So we're going to talk a little bit about the symbols. So what does that first symbol mean? Micah? Equal. So this means equal to. So an example of this would be something like 3 plus 5 equals 8. Should be writing this down in your module. What does our next symbol mean? How do we say that one? Cannon?
Guys, if you didn't have your module, I gave you the copies for this. You should be copying it down as well.
How do we say the next symbol? Greater than. So this is greater than. So an example of a greater than would be 12 is greater than 4. The next one would be what? Yes. Less than. So an example would be -2 is less than 0. Who does our next one? JJ? Close. We actually reversed the way you said it, though. Good. So we say that as less than or equal to. Now, this may not seem like much, but in the whole universe of numbers, the difference between the less than and the less than and equal to is one number. That now makes it a true statement. So, for example, is 7 less than 7? No. But is 7 less than or equal to 7? Yes. So now 7 just went from a false answer to a true answer because I changed it to a less than or equal to. Okay? So, for example, less than or equal to, I could say -8 is less than or equal to 16. It's less than or equal to. No, it doesn't have to be. Anything less than or equal to 16. Okay? So now, what does our next one say? How will we say this one? Deanna? Well done. Greater than or equal to. So, for example, 7 is greater than or equal to 7. So this is now a true statement because I added the equal to sign to it. Good. We're going to skip the rest of this page because we're going to try to finish this up before lunch. Let's go to the next page. This one, all we're going to do, we're going to substitute the indicated value into the variable and state in a complete sentence whether the resulting number sentence is true or false. If true, find a value that would result in a false number sentence. So there's one task. If false, find a value that would result in a true number sentence. So there's a second one. So basically, we're going to put the number in, say, is it true or false? If it's true, we're going to find a false value. If it's false, we're going to find the true values. Okay? So our first one, we're going to substitute 8 for x. So all I'm going to do is rewrite this. Instead of the x, I'm going to put an 8 in there. So now I have 4 plus 8 equals 12. 4 plus 8 equals 12. Does 12 equal 12? Yes. So that is a true statement. So now I need a false statement. What would make this expression false? Andrew? No, because this was the one they've given us. Like, I can't change the sign. We got to use equal. Shannon? 4 plus what? 6? Is that the only other option? What options do I have that would make this false? Good. So any number but 8 makes this false. And that's where we answered in a full sentence to say, how can I change it? Okay, now let's do a substitution. We're going to do 4½ for g. So I'm going to do 3 times 4 1/2 is greater than 15. How do I multiply a whole number and a mixed number? How do I multiply a mixed number and a whole number? Wesley? Good. So I make them both improper fractions. For the whole number, I just put it over 1. For the mixed number, I'm going to slam dunk. 2 times 4 is 8, plus 1 is 9. So then I say 3 times 9 is 27 over 2 is greater than 15. To make it so I can understand this, let's divide 27 by 2. It's going to give me 13 1/2 is greater than 15. So is that true? This is a false statement. So now I need to know what's going to make it true, because I have to change it. So how would I make it? What number could I put in for g to make this true? Alyssa? 5? So is 15 greater than 15? 6? Is 6 the only number I could use? No? Anna? Any number greater than 5. Makes this true. Does that make sense? Okay, let's try our next one. F over 4 is less than 2. Let's start with 8. So 8 over 4 is less than 2. Is 2 less than 2? No, it's not 2 isn't less than 2. So this is false. So what will make it true? Krista? Any number less than 2? Any number less than 2? Remember, what am I doing to my variable? I'm dividing it by 4. So are there numbers larger than 2 that would still make this true? If I put 4 in, 4 divided by 4 is 1. Is 1 less than 2? So I still use some numbers bigger than 2, can't I? JJ? Oh, you just wanted to look like you knew until I called on you? Nora? Greater than 2? So if I use a number bigger than 2, say 12, a number less than 2? We just did 4. 4 worked.
Guys, we're focusing on the variable. What is the variable?
The variable is being divided by 4.
What is F? What is F? What did they tell us F was? 8. 8. So that's the number you need to be focused on is 8.
Because we found the boundary, right? Any number less than 8. So any number less than 8 makes this true. Okay, we'll pick up after lunch. Okay, let's finish up these last couple, and then we're going to get into the rest of the lesson. So number 4. 14 and 2 tenths is less than or equal to h minus 10 and 3 tenths. Substitute 25 and 8 tenths. So we'll rewrite it. 14 and 2 tenths is less than or equal to 25 and 8 tenths minus 10 and 3 tenths. So we need to do that math. Remember, when adding or subtracting decimals, the key rule is lining up my decimal places. Now I just subtract. My decimal place comes straight down. So, is 14 and 2 tenths less than or equal to 15 and 5 tenths? Is that true or false? True, because 14 is less than 15. So now I need to figure out where is it false. Now this one gets a little more complex because I'm taking away 10 and 3 tenths from the number to get to 14 and 2 tenths. Ayana? $24 and 1 tenth? I think you went the wrong way. Greater than what? Are there numbers less than 25 and 8 tenths that would still make it true? So where's my borderline? No, because those two numbers aren't close, are they? Because this goes all the way till it's equal to, right? 24 and 2 tenths, is that equal? If I take 24 and 2 tenths and subtract 10 and 3 tenths, what do I get? 24 and 5 tenths. Now I think you're good, so let's look at that. If I did 24 and 5 tenths, take away 10 and 3 tenths, now I'm at 14 and 2 tenths. Okay, this is true, so what is going to make it false? If the number is less than or greater than 24 and 5 tenths. Really? Because we did 25 and 8 tenths and it was still true. You'll get into this as you get into more advanced algebra, guys. But when you're doing inequalities, a really good way to check is pick a number that is bigger or smaller than what you're looking for and see if it's a true statement. If it's a true statement, it means it's in its solution set. So I know 24 and 5 tenths is my borderline. That's where it equal. I know 25 and 8 tenths was true. So I need a number that is less than that to make it false. Part of the problem on this is we're doing kind of a double negative. I want to find something that's going to make it false. You're used to always trying to find something to make it true. So any number less than 24 and 5 tenths will make this false. That was what I really wanted to do to make sure you guys understood that. Okay? So let's go ahead and go back to our packets that we handed out now. We're going to go to the front page of it. You can close your modules. We won't be coming back to the modules. Guys, it's on the board. Shouldn't take a whole lot of talking. Okay, we're going to go through some vocabulary definitions first. So our first definition, a sequence is a series of numbers related in some fashion. So as long as there is some type of relationship that I can understand between the numbers, that is what we call a sequence. So here's a really common example of a common sequence. Normally what you're going to do is you're going to see a series of numbers, and then you're going to be asked to figure out, for example, the next three in the sequence to see if you really understand what the pattern is. So guys, look at that series of numbers that I put up there. See if you can tell me what the next three numbers in this sequence are going to be. Figure out what the relationship between the numbers is, and see if you can figure out what the next three numbers are going to be. JJ, you think you see it? What is it? No. Maddie? Then what? Okay. So she did find the next one. 34. And then? So what was the pattern that she saw? She said, okay, well, 1 and 2 were the first two numbers. If I add those two together, what do I get? 3. Then the next two numbers were 2 and 3. If I add those together, I get, then I add 3 and 5, I get, you see the pattern? Okay? So that is just an example of a sequence. A term. Term, we're going to put a couple different definitions up here. So a term is a number or variable in an expression or part of a sequence. So, for example, 2x, that has two terms in it. The first term is 2. That's a constant. The variable is x. Or we could talk about our sequence. What would be the fifth term in our sequence? What would be the fifth term in our sequence? No, the sequence that we already have up here. The fifth term would be the 8, because that's the fifth term in the sequence as I start from 1 and start counting up. Okay? Now, within sequences, we have a couple of very special ones. In an arithmetic sequence or arithmetic sequence, this one is a sequence found by addition. Now, I'm going to add a caveat on that. If I have the same number that I'm adding every time, what's another way we could say that? So it's going to, some of them will look like multiplication, but they're still arithmetic sequences. But for example, if I have a sequence such as this, 3, 7, 11, 15, 19. Who knows what the next three terms would be? Madam? Good job, because what was I doing each time? Okay, so all I'm doing each time is I'm adding 4. This makes it an arithmetic sequence. Now, geometric sequence, this one, a sequence is found by multiplying. Now, the big thing on a geometric sequences change very drastically, very quickly. So an example of a geometric sequence would be 15, 30, 60, 120. So what's happening here? Nora? I'm multiplying each number by 2. So now my next three would be, I multiply 120 times 2, I get 240. I multiply that by 2, I get 480. I multiply that by 2, I get 960. So one of the big things you'll see in a geometric sequence, you're seeing really large steps. In an arithmetic or arithmetic sequence, they tend to be much smaller, very even changes in between the numbers. Okay? So determining whether a sequence is arithmetic or geometric can help you find the pattern. Once you know the pattern, then you can continue the sequence. So our first one, find the next 3 terms of the following sequence, determine if it's arithmetic or geometric. Where'd I go? There we go. So the numbers were 7, 14, 21, 28. What are the next 3 going to be? Alyssa? Good. 35, 42, 49. So is this an arithmetic or geometric? Arithmetic, so I'm just going up by what? Plus 7. So I'm adding 7 each time. Now, this being said, don't be confused. If I'm going down, it's still an arithmetic sequence. It's just I'm adding a negative number. Okay? Find the next 3 in the next one. 2, 4, 8, 16. JJ? What are my next 3 terms? Good job. So that's a geometric. What am I doing each time? Multiplying by times 2. I did an x2 earlier and had an uprising, so we'll just use the dot. So I'm multiplying it by 2. Okay, find our next 3 terms on the following sequence and determine arithmetic or geometric. So 4 and 5/10, 4. 3 and 5/10, 3. You know it? No? Micah? So 2 and 5/10, then 2, and then 1 and 5/10. So which type is that? An arithmetic, because what am I doing? Minus what? Minus 5/10. Okay, find the next 3 in this one. And then determine arithmetic or geometric. So 0, 15, 30, 45. JJ? What are my next 3 terms? Okay. And 90. Is this arithmetic or geometric? And what is my pattern? What am I doing? Adding 15. Okay, now, go ahead and turn the page. Because this is going to be very similar to what your homework is. Now, if I have a sequence, I can actually look at the patterns, and I can build a rule so that I can figure out any number in that sequence. So I have to be able to analyze the numbers and see how are they changing. Okay? A lot of it has to do with what position they're in. So if I look at this and I say, okay, my first 4 positions that they gave me, the numbers are 8, 16, 24, 32. What I'm really asking is saying, if I have some number n, how do I go from here to here every single time? What do you think, Wesley? Add 8. But now I'm doing this every time. I want to put a variable in there. So could I just put a variable of plus 8? I'm adding 8 every time, but if I'm putting it in terms of my position, what am I doing? Lasena? Multiplying by 8. So the rule I would develop is 8 times the term, or 8n, will tell me what the answer is. Okay? Now let's look at our next one. We have 3, 6, 9, 12. So my first 4 positions are 3, 6, 9, 12. So how do I go from the top to the bottom? What am I doing? Andrew? Good. So my rule would be what? Good. 3 times n. Could I write that as n3? No, we can't do that, right? Even though it would equal the same, we don't write it that way. Well, okay, number 3. Now let's look at it. Now they started us at 2. So I go 2, 12, 3, 18, 4, 24, 5, 30. What's my rule here? Alyssa? Times what? 6 times n. So my rule is 6n. But now we're going to do something new. What would the 10th term be equal to? Madison? Yes. All I do is I put 10 in for the n, and now I can figure out the 10th term would be 60. So I'm just multiplying it by 6. Now our next one's where it's going to get a little tricky. Let's see if you guys can pick it up. I'm going 3, 7, 4, 8, 5, 9, 6, 10. Wesley? N plus 4. Excellent. You got it right off. So the first key of that is realizing I'm only going up by 1 each time. That automatically should tell you you're doing addition. I just have to figure out what number I'm adding to get that value. So n plus 4, what would my 8th term in this sequence be? 12. Good job. Okay. Number 5. 3, 12, 4, 13, 5, 14. How is this one changing? Ayana? And plus 9. So I'm adding 9 to the term each time to figure out what the new answer is. So my 12th term in this sequence. Oh. I was like, well, I have made mistakes today, so. Gabe? I didn't know you became a ventriloquist, Gabe. It means I asked Gabe and Kaylee answered with the answer. Right, but I asked Gabe. 21. Okay, our last one. 2, 24, 3, 36, 4, 48. Rosana? 12 times n is my rule. So what is the 12th term in this sequence? Good? Rosana? 144. Are you guys starting to see how these fit together? Okay, let's turn the page. Unfortunately, we're almost out of time, so we're not going to give you a whole lot of time to practice, but we'll give you guys about 3 minutes. See how many of these you can finish out. Develop the rule, and then figure out what that term that they give you is. Don't worry about the homework. We'll talk about that in a few minutes. Okay, so our first one, 2, 8, 3, 12, 4, 16. Rule for n, 16th term. 16 times 4 gets me 64. 8, 14, 9, 15. Now I'm just adding because it's only going up by ones. So it's n plus 6. So the 16th term is going to be 22. Our next one, 11, 4, 12, 5. Again, it's just going up by ones. 11 to 4, I'm going to subtract 7. So the 16th term, 16 minus 7, is going to be 9. Okay, this one, 12, 21, 12, 22, 13. These are just going up by a little bit. So that means I'm looking at an subtracting again. So I'm going in and I'm subtracting 9. So my 16th term, now I'm actually going to go back the other way, is only 7. Okay, we don't have time for these because I want to go over the homework. So turn to the next page. Here is your homework page. Okay, you only have 6 problems for homework, guys. This should be easy. But really key, you have 2 parts to every one of these. Make a table and write a rule. And they're going to tell you what you need to find the answers to. So my recommendation would be include those in your table. But if you want your tables just be 1, 2, 3, 4, that's fine. But make sure you use your rule to answer this portion of the question. Is that clear? Okay, so you only have 6 problems for homework tonight. Make sure you bring your modules every class, guys. Don't forget the quiz is next class. Good luck.